So what I want you to focus in on is if you plug x equals 100 into the leading term, the number you are getting for that leading term. And I want you to see that it is a very large positive number. So what you're going to do when your homework comes up is you're going to look at this polynomial and you will have to decide, as x approaches positive infinity, what does f of x approach? And I want you to see that if you are dealing with a positive 5 for your leading coefficient, positive infinity is what you're going to get out. And adding these lesser degree terms onto that gargantuan x cubed, they aren't going to affect it. They're going to be like going, I'm going to subtract 1,000 from you. And this number's like, you're a joke, go away. Then I want you to look at the second polynomial. And you have exponent 3 and exponent 2. Identify that leading term along with the sign of the coefficient, because that is really important. So the entire leading term, not just the leading coefficient, the whole term, negative 2x cubed. If I were to plug in just a simple x equals 100, that's on the way to infinity. You're getting a very large negative number. That negative 2 is causing a negative number. The x cubed is making it gargantuan. This is causing your f of x to approach negative infinity when x is approaching positive infinity. In other words, when your graph heads to the right, this polynomial will go up. This polynomial will go down. Now, there's a reason why I have all 4 of these. And you'll see in the next section, because I'm going to keep using these polynomials for a little while. Now, the next one, leading term. And I want you to notice you have a positive 3 leading coefficient. If you take the entire leading term and you plug in just a simple x equals 100 on the way to infinity, you're getting a very large positive number. For the last polynomial, your largest exponent is 6. The leading coefficient is negative 8. The entire leading term is negative 8x to the 6th. When you plug in x equals 100, you're getting a pretty decent sized negative number. And with what I just talked to you about, the addition of these lesser degree terms is going to change a small bit of it. But this is only x equals 100, and we're talking about x continuing to get larger and never stopping getting larger. And the adding on these much, much smaller numbers is not going to affect the final end behavior. And what I want you to see from these 4 is that the leading coefficient sign determines the right end behavior of the graph. You're going to be asked to determine end behavior. And I will tell you that the easiest way to approach it is to start with find your entire leading term. But for me, I first look at the leading coefficient being positive or negative, because that automatically tells me the right side. Positive leading coefficient, the right side heads up. Negative leading coefficient, the right side heads down. And you're going to be expected to write the notation that you see here and interpret what that is saying about the graph. Now, those same four polynomials. And what I'm having you do in this table is rewrite from the table above these three columns were from the table above. And now I want to separately have you think about if x is heading to negative infinity. Come on. This is why I don't use Word normally when I'm writing. So again, the leading term. Now, if I'm dealing with x cubed, when I have a positive number going into x, when I plug in, when I have a negative number going into x, I was at the wrong, hold on, let me push undo for a second. There we go. When I plug a negative number into x cubed, it stays negative. I multiply it by this positive 5. I'm getting a negative number. I want to point out that when the degree of a polynomial is the largest exponent. So this first polynomial is degree 3. That's an odd degree polynomial. And its left end is heading to negative infinity. And I want to show you that with the second polynomial, it is also an odd degree polynomial. So when I plug negative 100 into x, instead of plugging in positive 100, it actually makes the number come out positive because I am multiplying a negative number with another negative number. And that means that my left end is actually heading to positive infinity. And look at the very different patterns. I'm going to draw a nice glittery line. Look at the difference in the two patterns between the even and the odd. When I have an even exponent, it doesn't matter if I put in positive or negative. I'm going to get the same exact thing. So what you want to take from this is, once you determine the right end of the graph based on whether your leading coefficient is positive or negative, you can then look at whether your degree is even or odd. If your degree is odd, then your left end goes the opposite direction of your right end. If the degree is even, then your left and right ends go in the same direction. I want to make sure to show you a visual. If you go back to what we were looking at yesterday, take a look at the difference between the even and the odd. Even degree, either both ends go up or both ends go down. Same thing. But an odd degree, the two ends go in opposite directions, doing disco. Now in the classroom setting, this is where we get to have fun and exercise. And I give you an equation and you show with your body that it goes wee, or wee, or doing disco, or doing disco that way. And so we get to have a little bit of fun. I won't make the two lone people in here do that because that's very awkward when you're by yourself. But basically that, oh, I'm going back over here. Now I remembered. That is what we want to conclude. So here's your conclusion. If the degree of the polynomial is even, then the left end goes in the same direction as the right end. If the degree of the polynomial is odd, then the left end goes in the opposite direction of the right end. And then I'm going to hold this up for a second. Oh, okay, yes. So if you weren't here earlier, I went through a long excuse of why I don't have all my work done today. I am going to post homework corrections after class. I'm a bit behind too. So I'm going to give you extra time because I'm behind, and I'm not going to punish all of you for my behindness. And so I'll give you extra time. I still need to post the homework answers. You're not having a quiz today because I didn't get myself to a point of being prepared for it. I'm going to post the classwork answers during lunch because I'll have time to do that. I've just been this morning trying to play catch up after crying in my bowl of cereal. I'm joking, but I'm not 100% joking. Because when I tried to tell my son happy birthday, he just looked at me like, are you going to be emotional on me again? I imagine some of you may have a similar situation or an opposite situation. I'm the emotional one, and my son is the very, like, I don't understand these emotions. And so I often get that kind of like, what's wrong with you look. All right. Oh, and then if you didn't hear it, yeah. yeah, I realize it. It's also his 18th birthday, which is why I'm crying in my cereal this morning. Anyway, blah, blah, blah. All right. So here is a very important summary. This, you don't have to look back on all the work that we just did. You need to look at this summary. The work we just did was so that you can understand why this works. And I am telling you right now, if you understand what I went over with you just now about why these ends go the way they do, it is going to tremendously help you when we go into the next unit of rational functions. Everything we do in this unit is just polynomials. But next time around, it's going to be a polynomial divided by a polynomial, and there's a whole lot more going on with that. And you have to understand polynomials, or you're just going to be very frustrated when you hit the rationals. So understand how important this is. It's going to make your life easier by far if you understand this, particularly this. End behavior is a very important issue that's going to be even bigger of an issue in the next unit. So, I want to say again, I first look at, is the leading coefficient positive or negative? So as x approaches positive infinity, that means f of x is approaching positive infinity, and that means that the right end is up because of that. If you have a negative leading coefficient, then when x heads to positive infinity, f of x heads to negative infinity, and that means that your right end is heading down. Once you determine the right end behavior, then you're going to change to what you're looking at. And now as x is approaching negative infinity, if you have an even degree, if you have an even degree, then when x approaches negative infinity, you're going to get the same thing. But if it's an odd degree, you are going to get the opposite for the left side. And I'm trying to go back a little bit so I can't have too many highlights or it'll get confusing. So positive leading coefficient, even degree, right end up, left end, same. Positive leading coefficient, odd degree, right end up, left end opposite. Then over here, negative leading coefficient gives you that the right is heading down. Even degree means the left end does the same as the right end. They both go down. Odd degree, the left end heads in the opposite direction as the right end, and that causes the left end to head up if that right end is going down. Yeah. Let me dip. There we go. Now, actually, I don't think I have this in your notes. I don't know if you caught it, but I tried to make some changes due to the time limits that we are dealing with. And it's meaning I need to put in extra work to be able to get you the answers each time. And so if I'm not on top of it, yeah, we're here. All right, so here are some examples. First, use the graphs to determine if the degree is even, odd, and if the leading coefficient is positive, negative. So what I want you to do is you're first going to write down that as you look to the right, is the graph heading up or down? And then you guys look at the right and you see it's heading up. That means this. You don't have to write the words right and up, but know that that is the meaning of x approaching positive infinity means right, f of x approaching positive infinity means up. And then look at the graph. When x heads to negative infinity, I'm looking to the left. It's heading down. And now if you are thinking about what you just observed, Does that tell you you are dealing with an even degree or an odd degree polynomial? And hopefully you see opposites, odd degree. Is your leading coefficient positive or negative? You're looking primarily at just what's the right end doing. The right end is heading up. That means positive leading coefficient. Know that the reason I'm having you write this down is because you're expected to get used to this formal writing right there. And I'm trying to continue to show you this formal writing with the picture, the visual picture, to help you see exactly what it's saying. Now, next polynomial, look at the graph. You can see that the right end goes up, the left end goes down, and if those are opposite, you have an odd degree. The leading coefficient is positive because of the right end heading up. And then the next two, we're doing the same thing again, and I have 5 more minutes left. I can do this. This is also probably another reason why it's good I didn't have a quiz today anyway. This section is extremely important. It may be the most important section, where understanding what's going on is vital. It's going to help you with so many things in the future. So here, right end goes up, left end goes down. Because of that, you're going to say when x is heading to positive infinity, positive. When x heads to negative infinity, negative. That means it's an odd degree because they are opposite signed. And your leading coefficient is the right end. It is positive. So way too many examples of that, apparently. Then over here, the right end heads down. The left end heads down. If they're going in the same direction, even. The fact that the right end heads down, leading coefficient is a negative. The next examples, you have the equations, and this is our last piece. So what I want you to do is look at the equations, and you can see the degree. Largest exponent is a 1, odd degree. The leading term is positive 2x. The leading coefficient is positive 2. So I have a positive leading coefficient. What does that mean you are able to say about the end behavior if you were to look at the graph? The leading coefficient being positive tells me my right end is positive infinity. So know that this matches that. Then the fact that this is odd degree says I'm going to do an opposite sign for the other end. Visually, you want to be able to see that if you have a drawing on an XY plane, right end up, left end down is what you are expecting to see. Now you know how to draw the equation of a line, and you know that this is giving you a positive 2 slope, so you should see that this is the end behavior. But then we're looking at some higher degree polynomials next. So find your largest exponent. Look at your entire leading term. Your entire leading term is x to the 4th. the degree is even because that's a 4. Your leading coefficient is positive because there's an understood positive 1 in front. The positive leading coefficient tells me that the right end heads up. The even exponent says same answer, and both ends head up. And then number 7, last one. Look for your largest exponent, 3. Take the entire term, and then you're looking at, let me keep my color coding. Okay, hold on, because we're almost done. This is an odd degree. The leading coefficient is negative. The fact that the leading coefficient is negative says the right end goes down. The fact that it's an odd degree says that the left end does the opposite sign and goes up. And that's everything you need to know. And in the next 20 minutes, I'm going to be posting all the stuff I should have posted this morning, meaning you might get a little bit of extra time to get stuff done. Ha ha! Woo! I will see some of you tomorrow, and I'm going to try and get some more stuff done, but I'm sorry I'm a little bit behind. And those of you who are here, I hope you enjoy your day on campus, because this is, I did not realize it was going to feel this crazy amazing to be somewhat normal. Yeah, I'm so blown away. Yesterday and today, I'm overwhelmed. And I can't imagine for you guys, you just get to go once a week. So that's like your whole. Oh man, that's yeah. I've got my alarm set a half hour earlier than I was doing, and that part I don't enjoy, but being able to see people and like, I didn't even know what you guys looked like. And you guys left your nameplates on your desks, right? Okay, because I just want to make sure people don't sit in same seats and try to keep us all well. So good to meet you. Okay, people who are here still online, did you have any questions or anything you needed at all? I hope to be seeing some of you on campus. And I see, hold on. I'm going to have to restart my computer to be able to hear what you're saying. I don't know why, but my sound coming in is not working. So are you able to type what you're wanting to say? Am I able to go back to number 2? And then number 2 would be this one. With number 2, let me emphasize, I'm going to shrink that down a little bit. If you didn't catch that, x approaching positive infinity means right end. And then the fact that the right end heads up means that f of x heads to positive infinity because that's y. And then x heading to negative infinity means you're looking at the left end. And you want to notice that you're heading down on the left end. So as x approaches negative infinity heading left, f of x approaches negative infinity heading down. And the fact that these are opposite signed is why it's an odd degree. For the leading coefficient, you're looking at the right end. So the fact that this is a positive number is why this leading coefficient is positive.